In section 3.6, we're going to talk about critical points and extrema. A critical point is a point on a graph where a line drawn tangent to the curve is either horizontal or vertical. There are three types of critical points, and two of them are ones that you are very familiar with. One of them is the maximum. A high point on a graph is called a maximum. There's my tangent line. And a maximum occurs when a graph was increasing and then switches direction to decreasing. That's really terrible. Let's try that again. So this side is increasing and this side is decreasing. A minimum is a low point in the graph. A minimum occurs when the graph was decreasing and then changes direction to increasing. And a point of inflection occurs when the curvature changes, but the graph doesn't actually change direction. This graph was increasing, and it's still increasing, but its curvature changed some in the middle. There are two types of maximums and minimums that occur in curvatures. This is a minimum because it's a low point in the graph, but we're actually going to call it the absolute minimum. The reason it's the absolute minimum is because it is the lowest value on the function. This is also a minimum, but it's not the lowest point. Because it's a minimum but not the lowest point, we're going to call it a relative minimum. This is a maximum, but because both ends of the graph go up forever, this maximum is not the highest point, so we're going to call it a relative maximum. We can also have an absolute maximum. If I were to do this, this would be an absolute maximum. And all these maximums and minimums have a special name, and the special name we give them are extrema. Let's do an example where we need to locate and name and classify the extrema. So in this graph, we want to find all the places where the graph changes direction. So let's start over here. That ordered pair is -4, 3. It's at a maximum. But is that maximum relative or absolute? Is it the highest point on the graph? No, it's not. And the reason it's not the highest point is because if you look over here, this graph goes up forever. That means there is no highest point. So it's a relative maximum. This next ordered pair here, which is at 0, -1, is a minimum, but is it relative or absolute? Well, again, this graph goes down forever. When a graph goes up and down forever, it will not have a highest or lowest point. So all the maxes and mins in between are going to be relative. This ordered pair is at 3, 7. It's a relative max. And this ordered pair here is at 7, 1, and it's at a relative minimum. We're also going to talk about using the graphing calculator to help us find maximums and minimums, because not all maximums and minimums are going to be at nice integers. So in example 2, we're going to use our graphing calculator to determine and classify the extrema of g of x is equal to x to the 4th plus 3x cubed minus 2. So first I plugged it into my calculator, and this is the shape of the graph. Well, clearly there is some sort of minimum down here somewhere. I don't know where it is, but I know there's a minimum down there. Other than that, the rest of the graph goes up from there. So in order to find out where that minimum is, and it's going to be an absolute minimum, we're going to use a function on our calculator called minimum. So you're going to press second trace. And you'll notice we've been here before. We've used the intersect function. Well, there are some other functions that are going to help us out. We're going to use minimum and maximums, number 3 and 4. Now you have to know what you're looking for. If you're looking for a minimum, you're going to choose minimum. And if you're looking for a maximum, you'll choose maximum. We're looking for a minimum, so we're going to pick number 3. When you press number 3, down here in the corner, it now says left bound and question mark. What you're going to do is you're going to take the flashing dot, which is probably right here, and you're going to move it to the left. Keep pressing to the left until your flashing dot is to the left of the minimum. And it doesn't even matter where, as long as it's to the left of the minimum and you see it flashing on the left side of that valley. And then hit enter. Then you're going to move it to the right bound. Now it says down in the corner right bound question mark. So now you're going to move that dot somewhere over on this side before you hit enter so that you're on the right hand side of that valley. And then when you hit enter, it'll say guess question mark at the bottom. Hit enter a third time, and at the bottom of the screen it should say there's a minimum, and that minimum is at approximately negative 2.25 comma negative 10.54. The textbook is another way of utilizing the graphing calculator to find a maximum or minimum, but it's kind of a silly method. Remember that when doing homework, you can also utilize Desmos. Now let's do an application problem of finding Extrema. Malik Davis is a soybean farmer. If he harvests his crop now, the yield will average 120 bushels of soybeans per acre and will sell for 48 cents per bushel. However, if he knows that if he waits, his yield will increase by about 10 bushels per week, but the price will decrease by 3 cents per bushel per week. If X represents the number of weeks Mr. Davis waits to harvest his crop, write and graph a function P of X to represent his profit. So his profit is the amount of bushels times the price. And he's going to start with 120 bushels, but he's hoping to gain 10 bushels per week. The price is normally 48 cents, but if he waits, it's going to decrease by 3 cents per week. So my function P of X is 120 plus 10x times 0.48 minus 0.03x. Now, in order to graph this, we're just going to do it in the calculator. We're not even going to multiply this out. That's the nice thing about using a graphing calculator application, or even Desmos. You don't have to multiply this out in order to look at the graph. Now, here's what my graph looks like, but I want to talk to you about how I changed the window on my calculator so I could see it. If you do this problem on Desmos, you'll probably play with the zoom in and zoom out function in order to see the graph. But I couldn't see my graph on the standard viewing window. So I went to the window function and I said, well, because X is the number of weeks, I can't have negative weeks because you can't go backwards in time. So I made my X minimum 0. And then I played with my X maximum a while. My X maximum here is actually 20, but I actually played with several numbers. I started at 100, and then I kept lowering it until I had a nice graph on my screen. My Y minimum, which is my profit, I can't make negative dollars, so my Y minimum is going to be 0, and my Y maximum, again, I started with 100, and then I decided to play around with that number until I found something that looked nice. So I ended up using 80. That's the scale on my window, and I got this nice graph. So now we want to find two things. Even though these are two separate questions, we're actually going to answer them at the same time. We want to figure out how many weeks should Mr. Davis wait in order to maximize his profit, and what is the maximum profit. So now I'm going to go back to this graph, and I can see that the maximum occurs somewhere in here. So I'm going to go use that maximum function that's under second trace. Number 4 is maximum. When it says left bound in the bottom left corner, I would probably move my cursor, the little flashing dot, all the way to the far left of this graph. Then hit enter. Then when it says right bound, so I should do this. I would probably move it over here for my left bound, and then I would probably move it somewhere in that general region for my right bound before I hit enter. And then when it says guess, hit enter a third time, and it says down at the bottom that the maximum is at x equals 2, y equals 58.8. X was the number of weeks, so that means we should wait 2 weeks before we harvest, and we'll make a maximum of $58.80. So now let me ask this. What are the risks of waiting? You know, we said if he waits to harvest, then he can get more bushels of soybeans, but it decreases the amount of money he gets per bushel because he waited so long. Are there any risks to waiting? Well, you know, what happened if bad weather came through and destroyed all the crops because he decided to wait an extra week when he could have harvested last week and not had this happen? You have to think about all the things in a problem that could affect the outcome. And that is critical points and Extrema.